Hold this piece of pottery in your hand. It's rough, beige, and full of neat little holes. It was made in what's now Poland more than 7,000 years ago, and it looks oddly familiar. Like somebody dropped a modern kitchen colander into a Neolithic rubbish pit. For decades, archaeologists wondered what it was for. Then chemists tested the fat soaked into the clay. Milk fat. This battered pot had probably been used to separate curds from whey. In other words, we're looking at a very old cheese-making tool. Most adults in that part of Neolithic Europe probably couldn't handle much lactose, yet people still bothered to milk animals. Why? Fresh milk wasn't the only thing they made. Milk contains lactose. Your small intestine uses an enzyme called lactase to break it down. Babies make plenty, for obvious reasons. In the ancestral pattern, production drops after weaning. Biologists call that lactase non-persistence. Without the persistence trait, one sip doesn't automatically ruin your day. Some lactose may pass undigested and cause nothing. A larger dose may mean gas, cramps, or diarrhea. It varies by person, by gut microbes, and by the food carrying it. That's lactose malabsorption. Intolerance is when symptoms actually appear. Neither is a milk allergy, which is an immune reaction to milk proteins. That variability still exists. Roughly 2/3 of people worldwide malabsorb at least some lactose, yet many can handle a modest amount without much trouble. A modern tolerance figure can't tell us what one Neolithic farmer ate, but it does kill the idea of a bright genetic line between can use dairy and cannot. Early dairying wasn't an all-or-nothing dare. Nobody had to drink a huge bowl of fresh milk on an empty stomach. We know they used dairy because unglazed pottery keeps chemical fingerprints. Animal fats seep into the clay while a pot is used. Thousands of years later, researchers can extract those fats and examine the carbon isotopes in particular fatty acids. Ruminant milk fat leaves a different pattern from body fat. Using that method, archaeologists have found direct evidence of milk processing in pots from the 7th millennium BCE, especially in northwestern Anatolia. That's around 9,000 years ago. The evidence stops at milk processing. A lipid stain can't tell us whether the pot held fresh milk, sour milk, butter, yogurt, or curds. It definitely can't show somebody happily chugging from it. We know dairy reached the kitchen. We don't know its form. Earlier milk use may have left no trace at all. A hide bag or wooden bowl doesn't survive like fired clay. Archaeology usually hands us a minimum date, not the birthday of an idea. It also favors certain chores. A pot remembers fat because fat sinks into the walls. It won't remember a child milking a goat, someone sipping from a wooden cup, or a batch that's spoiled before dinner. What survives is a biased little sample of an ordinary kitchen. The holes in the Polish pot suggest one likely use. Warm milk starts to sour and set. Pour it through the clay and the curds stay behind while the watery whey drains away. Much of the lactose goes with it. Fermentation removes some more. Age the curds, and the food may contain far less lactose than the liquid you started with. Nobody needed to know the word enzyme to notice the result. One form of milk made your belly complain. Another didn't, or at least not as much. Straining also solved a second problem, possibly the more important one. Fresh milk spoils quickly. A dense lump of curd is easier to carry, trade, and save. Neolithic cattle often calved seasonally, so milk may have arrived as a flood followed by a drought. Preserving some for later would have been useful. We can't say that's why cheese was invented, only that lactose wasn't the sole problem a strainer could solve. It is, basically, a pantry technology that happens to be delicious, and milk itself was worth the trouble. Kill a cow and you get one large delivery of meat. Keep her alive, and after feeding her calf, she can give you food again and again. Sheep and goats do the same on grass and scrub that humans can't digest. A herd becomes a machine for turning a landscape into recurring fat, protein, and water. That could help a farming family bridge the hungry weeks before harvest. For mobile herders, dairy travels on 4 legs until you need it. On the Eurasian steppe, widespread dairying appeared alongside the rise of highly mobile pastoral life. It probably helped that system work, though milk alone did not launch entire populations across the continent. Other kitchens were doing this too. Pots from a much greener ancient Sahara carry dairy fats from nearly 7,000 years ago. Milk proteins have been found trapped in the dental plaque of ancient people in eastern Africa. In Bronze Age Mongolia, researchers found cow, sheep, and goat milk proteins in human dental calculus, even though the people tested showed no genetic evidence of lactase persistence. The food had outrun the gene. Europe shows that delay especially clearly. Dairy residues appear from the beginning of farming, but the main European lactase persistence variant is absent from almost all early Neolithic people sampled so far. The earliest carrier in one large dataset lived around 4,700 to 4,600 BCE. The variant only reached noticeable frequencies much later, around 2000 BCE. Even at the Tollens battlefield in northern Germany, about 3,200 years ago, researchers estimated lactase persistence at just 7%. Today it's common across northern Europe. That's an astonishing rise in a short evolutionary window. Natural selection didn't decide that milk was good and redesign everyone. People with a helpful variant simply left, on average, a few more surviving descendants under whatever local pressures made the trait useful. In places where processed dairy already worked well, or milk mattered less, that advantage could be weak or absent. It also didn't happen through one universal milk gene. The familiar European variant sits in a regulatory region, a genetic switch that helps keep the lactase-making machinery turned on. African and Middle Eastern pastoralists evolved different variants that did something similar. Dairying changed the environment in which selection worked. Adult milk digestion became common later, and only in some populations. Processing already made dairy tolerable, so fresh milk digestion needs another explanation. Extra calories are one candidate. A person who can drink fresh milk has more options and may absorb more energy. Yet a huge European study found that places and periods with more evidence of milk processing didn't neatly predict the rise of the persistence variant. Its model fit better when famine and infectious disease were included. In an ordinary year, a non-persistent adult might avoid fresh milk, drink a little, or accept some discomfort. During a crop failure, that choice changes. If the herd is still producing, raw or lightly processed milk may be the food available. Now imagine the same person is malnourished, dehydrated, or already fighting an intestinal infection. Extra diarrhea is no longer an inconvenience. It can be deadly. Crowded settlements may have created a similar pressure. More pathogens and gastrointestinal disease meant less room for another source of fluid loss. If crises like that returned often enough, even an occasional survival difference could change the frequency of the trait over generations. That's a strong hypothesis for Europe, not a solved case. Famine and disease in prehistory are reconstructed through proxies, population changes, settlement patterns, animal use. We don't have a witness statement from a failed harvest in 3000 BCE. Different regions may also have favored lactase persistence for different reasons. Dry climates, safer fluid, nutrition, or pressures we haven't identified. Early farmers did not spend thousands of years grimly forcing down milk until evolution finally gave in. They soured it, strained it, and ate portions they could handle. Across Africa, Europe, and Asia, dairying flourished among people whose genes did not guarantee an easy glass of fresh milk. Later, in some populations, being able to drink it directly became an advantage strong enough to leave a visible mark in ancient DNA. That perforated pot preserves the part we tend to miss. People found ways to change milk long before adult milk digestion became common, and in much of the world, it never did.